time ever an object from interstellar space has been observed to visit our solarist in the vast expanse of space. Humanity has only begun to explore, despite our limited understanding. We've long wondered about life beyond Earth, sometimes thinking we're alone in the universe. But everything changed when Oumuamua, our first interstellar visitor, arrived. This mysterious object opened our minds to the vast possibilities beyond our planet. Recently, astrophysicist Neil deGrasse Tyson shocked the world by revealing never-before-seen images of Oumuamua. Who sent this extraterrestrial messenger? What's the Yorp effect and its connection to Oumuamua? Let's journey into space with Tyson's knowledge to uncover the mystery. Back in 2017, the Hikala Observatory in Hawaii made a groundbreaking discovery. Initially mistaken for a comet or asteroid, further examination revealed Oumuamua as the first interstellar object detected within our solar system. Its slanted orbit and high speed indicated it came from beyond our system, earning it the Hawaiian name Oumuamua, meaning a messenger from afar. Arriving first, this celestial visitor puzzled astronomers with its irregular brightness variations and elongated shape, sparking theories about its origin and purpose. Some suggest tidal forces may have stretched it into its cigar-like form, similar to the elongated asteroid Idaho. However, Oumuamua's unique characteristics, like its remarkable acceleration and trajectory, continue to intrigue scientists. Oumuamua's swift speed, even surpassing that of human-launched objects, adds to its mystery. It zipped past the Sun and ventured below the planetary plane with incredible velocity, hinting at a significant kinetic energy reserve. As we delve deeper into the secrets of this cosmic wanderer, we're poised to unravel more about the enigmatic nature of our universe. Oumuamua's rapid pace has sparked speculation that it might have come from a binary star system. This theory suggests that gravitational forces within such systems could eject objects at high speeds, potentially explaining Oumuamua's velocity. Another possibility is that interactions with celestial bodies in its home system, like planets, could have acted as gravitational slingshots, propelling Oumuamua forward. However, more research is needed to confirm these theories. But Oumuamua's intrigue extends beyond its speed. Studies have uncovered fascinating insights into its makeup. It boasts a thick outer layer akin to a cosmic shell, formed from carbon-rich materials solidified by cosmic radiation during its journey. Beneath this layer lies a dense core, primarily composed of rock, possibly with traces of metal and notably lacking water or ice typical of comets. Its reddish tint, a result of prolonged exposure to cosmic rays, adds to its mystique. Some experts, including Neil deGrasse Tyson and Michio Kaku, have been sought for their perspectives on Oumuamua. Tyson, in particular, refrained from commenting until substantial evidence, including recent declassified photos, became available, heightening anticipation for his insights. The object's elongated shape suggests it might be a fragment of a larger body, possibly torn off during a collision. This event could have imparted the high velocity observed in Oumuamua. Unlike comets, which exhibit gas and dust due to their volatile composition, Oumuamua displayed none of these features. Its velocity far exceeds that of most asteroids in our solar system, emphasizing its uniqueness. However, the most intriguing speculation surrounds the possibility that Oumuamua is not a naturally occurring object but rather a meticulously crafted creation of an advanced extraterrestrial civilization. Proponents of this theory, like Avi Loeb, suggest it could be part of an alien spacecraft or equipment designed for exploration. Loeb's hypothesis has sparked intense debate within the scientific community, adding another layer of fascination to the mystery of Oumuamua. It's worth noting that many scientists and astronomers have expressed skepticism regarding claims suggesting Oumuamua's artificial origins. The prevailing consensus among most scientists is that Oumuamua is likely a natural object, such as a comet or an asteroid, with its unique properties arising from natural processes. Researchers, including Wesley C. Fraser, have examined Oumuamua's rotation and concluded that its brightness variations cannot be explained by a simple rotation period. Instead, it appears to be tumbling in an excited rotational state, a motion unlike anything observed before. This irregular rotation, completing a full turn every 7.3 hours, has puzzled scientists since its discovery. Various theories have been proposed to explain Oumuamua's tumbling motion. One hypothesis suggests spin-induced outgassing, where volatile substances beneath its surface vaporize due to solar radiation as the object tumbles through space, creating tiny gas jets that cause irregular spinning. Another theory posits that a prior collision distorted Oumuamua's shape, setting it into its irregular spin. Comparisons with other celestial objects, like the asteroid 4179 Totatus and comet 67P/Churyumov-Gerasimenko, which also exhibit irregular rotations, provide valuable insights. The Yorp effect, where sunlight exerts torque on an object due to uneven thermal radiation, is one proposed mechanism for Totatus's erratic rotation. Similarly, 67P's irregular rotation is attributed to outgassing and volatile substances from its surface. These similarities hint at potential underlying mechanisms responsible for Oumuamua's peculiar spin. Further exploration and analysis of such objects can provide valuable insights into Oumuamua's nature. Speculation about its origin ranges from being a fragment ejected from its home star system due to gravitational interactions to a byproduct of a collision between two objects in a distant system. However, without more evidence, these theories remain speculative. Detailed analysis of Oumuamua's composition, isotopic ratios, and surface features could provide crucial clues about its origin and shed light on the mechanisms behind its peculiar spin and movement. The absence of visible emissions from Oumuamua eliminates the possibility of it being a typical comet or asteroid, presenting an intriguing puzzle that demands further investigation. There's a possibility that Oumuamua's lack of emission could be explained by it being a dead comet. Typically, comets emit visible trails as their icy composition vaporizes near the Sun. However, if Oumuamua lost most of its volatile materials during its interstellar journey, perhaps due to close encounters with stars, it might lack the usual comet features. This could suggest it's more like an interstellar asteroid. Asteroids typically don't emit visible trails, and their shapes can vary widely, unlike Oumuamua's elongated form. Some scientists suggest this shape could result from gravitational distortions during close encounters in its parent star system. Asteroid Bennu, for example, observed during NASA's OSIRIS-RX mission, didn't emit visible trails during its close passes by Earth, consistent with its rocky composition. This aligns with the idea that Oumuamua could be an interstellar asteroid. Upon releasing declassified images of Oumuamua, Neil deGrasse Tyson took on the responsibility of exploring and explaining its nuances. He emphasizes evidence-based inquiry and suggests that Oumuamua might be a test of our technological and scientific advancement, as well as our readiness for potential contact. Tyson sees it as a challenge to our scientific paradigms and a test of our ability to collaborate globally in the face of unexpected cosmic events. He also explores broader questions about the possible message behind Oumuamua. Could it be deliberately sent as an interstellar emissary, carrying representatives from another star system? Tyson urges considering all possibilities, no matter how outlandish they seem, as the universe is vast and full of wonders yet to be discovered. Tyson's contemplation of Oumuamua's nature challenges our understanding of the universe and our place within it. His theories have vast implications, potentially reshaping our understanding of space exploration and the cosmos. Thanks for watching. Check out the video you see on your screen right now. It is unbelievable.